And then the unit test cases are quite similar that we have done already covered in our unit test cases. So in the benchmark test, we are going to have the same Spark config and we're using the same test file path. This is not a very, very big file, but still it is good for our test cases. And then we have created several type of benchmark tests. These benchmark tests are exactly same as what we created in our unit tests. So first of all, we will try to benchmark it without using any cache or persist. Because as we discussed in our previous videos that Spark will always try to like implicitly call various caching mechanism to optimize our code or optimize our performance. And then we have got a benchmark test with cache when we explicitly call this cache method. So that and then we call this group by key on the cache paired RDD. Here we were not using any caching. We will not calling cache explicitly, but we just rely on the Spark's inbuilt caching mechanism. So here this cache, as we know that this will just try to explicitly store the data into the memory because our data is very, very small. So I think this will be performance boosted because the small data which can be stored in memory it should be always be performant efficient. Only when we have got very big data and the whole data cannot be stored in the memory, only then memory and disk persistence would be helpful. So this is what we are going to test in other benchmark tests. So group by key with persist memory only. Then we calling explicit persist method and then passing the storage level as memory only. Similarly, we have got several versions of this, the same type of benchmark, but every time we are going to use different storage levels, the same way as we did in our parameterized test in the previous one. So here, as we learned in our unit test cases, so we have got various type of storage level possible: memory only, memory and disk, memory and only serialization, disk only, off heap, none, everything. So all these type of, I've created a benchmark test for each of them. So there will be several methods trying to like mimic the same different type of storage levels. Once we have created all this benchmark, then at the end, we will be having the main method in which we will passing the option builder to include our main class for testing. And then we can call this main method from outside this or from IntelliJ itself to actually run all those benchmark tests and give us the results. Just to revise what we have done, we just set up like two dependencies in our pom.xml, and then we included Maven Shade plugin. After this, we wrote our benchmarking test class in our Java's main source code. And after we have put all the benchmark, we have got this main method. Now, there are two ways we can run this main method. One way is to directly run it from here, and it will run inside this IntelliJ and then try to do it. But I think this is again going to be having the same problem as we did as we encountered in our unit test cases. We don't want IntelliJ to be actually allocating its own JVM memory, and there should be an extra overhead by the IntelliJ. The best and the ideal way, the correct way to do it, to do the JMH benchmarking testing is to run it from the command line. So I will open my command line here. As you can see that this is my main Java Spark code base. So here, first of all, we have to run ambient clean install. So once we run this ambient clean install, what it will do is that it will actually clean all those like targets in the target folder, whatever we have, it will clean that. We got a target folder here. This target is where our compiled classes are there. It will first of all clean it and then reinstall it. By reinstalling means that it will also create a final benchmarks jar. So benchmarks jar, as we discussed that here, our final Shade plugin will generate this benchmarks.jar, which will be used as for the JMH benchmark testing. So being said that, let's run this ambient clean install. I've already run this and I already got this benchmarks.jar in our target folder. So in that tower, you can see that there is a benchmarks.jar here. And besides that, we also have this our main snapshot jar, which is the bundle of all this type of different source code that we already created. So what we will do using this benchmarks.jar. Now, as mentioned that after we have done our ambient clean install and it will create this benchmarks.jar in our target folder, this is how we are going to run it from the command line. So by command line, I will run java -jar. I just pass this benchmarks.jar as my input parameter for this jar. And then we will copy this RDD cache persistence benchmarking, which is the name of our class. We can also implicitly call a particular benchmark method. For example, I can also call RDD cache persistence benchmarking dot group by key without cache or persist or dot group by key with cache. We can also run individual all those benchmark unit test cases, and we can also run all of them in one go. So this is what I'm going to do. I'm going to run it for all of them in one go, and this will actually take some time, but it will do all those like warm-up iterations and everything that we have configured in our top. So here we have, it will run for 10 times, and it will measure for 5 times, and then using 3 sets, and also it will take some time, and finally it will give me a final result. So I have run all these test cases before, and it took around like 30 minutes or 1 hour to run me all these test cases, all these benchmark test cases, and then we have got a result. And this is our final result. Now we can see that the lower score means that it took less time to perform them, and which is like more performant. As we can see that as in our unit test cases as well, because our data is very, very small. In that case, doing without any cache or persist give me the best results. And of course, I mean, if you're doing just the persist memory only, I mean, because it is small, these to me are giving the best performance. And as we go further, I mean, if you're trying to like involve memory and disk and memory and distillation, the performance is getting worse because because of such a small data. If we don't do any type of like explicit cache or persist, or we call the cache method in which we are showing to memory, that is good enough for the small data set. But if we are also including memory and disk, that actually involves a lot of like overhead, that it has to also like involve the disk for anything else. So this overhead cost is more than the actual performance gain because the data is so small in our test case. That file is not big. But only for the very huge data sets, right? Like with terabytes, petabytes and all, we may consider using memory and disk storage levels. This is what we also learned in our unit test cases that we did. And this is quite evident from this JMH test because this excludes all those JVM performance iterations and all. And this gives us the actual JMH, which is mimicking our production code. So guys, this was all about chapter 15, Spark RDD persistence. We learned a lot of things here. And finally, and then on the next video, we're going to cover chapter 16, which is Spark RDD closures and shared variables, in which we will discuss about accumulators and broadcast variables. So see you all in the next video.